Okay, let's start this master class. First, I want to all welcome all of you to select this class. And I think this class become more and more popular, though the name of this class is Clinical Decision Support System, but actually it's talking about how to use computer to help physician or the health caregiver to uh, care patient in clinical practice. So though the name of this class is Clinical Decision Support class, but actually the original name in this field is called artificial intelligence, such as the neural network and data mining and sort of thing. It's all talking about um, the similar thing. Then at the beginning, I want to introduce myself a little bit. Um, my name is Ming-Chin. I think all of you know me. Then I'm also the alumni of the Kimi. Then I was just like you, sitting in this class before. Then after I got the master degree from the Kimi, then I got my PhD degree from University of Utah, just like the president Jack Lee. We from the same institute. Then actually, he's also my advisor when I pursuing my master degree. And currently, I work in the Shanghai Hospital, and I'm a physician in the neurosurgery department. And right now, mainly in charge of all the computer or the robotic uh, associate thing, such as the ROSA spine surgery and the gamma knife or the focus ultrasound. So currently we have a department called AI and the robotic surgery. Then currently I'm the director of it. Then also, yeah, I'm also teaching in Kimi. Then I'm the assistant professor in Kimi. So that's a little bit introduced about my current background. And yeah, for this semester, about the rule about this class, then it's we will use the remote and unsynchronized mode to let you watch the course material whenever you want. And but that's for your convenience. But I'm also welcome sometime you want to discuss with me face to face. It's okay that you can set up the appointment with me. Then I will go to the course. Then you can have discussion with me. So mainly the class of this semester, we will the formula it will be like this. I will make a tutorial and a presentation about the clinical decision support related issue. Then you will hear some background and history. Also, I also want to let you get your hand dirty. So we will also prepare some uh, the hands-on course. Usually, I will distribute it a database. That's the head injury database. Then I will teach you how to use a data mining software called Week1. Then you can learn how to exercise some uh, artificial intelligence or clinical decision support related topic project. So you will also learn how to use the open source software to do the artificial intelligence work. So this semester, I will give you some introduction. Then we will also have some hands-on course. I will announce the time and the date and the place. then you will prepare your computer. Then everything you will, when you're ready, then I can teach you step by step how to perform the clinical decision support class. So that's since we are doing the unsynchronized, so you don't need to send me a leave of absence when you are not in the class or something. But in the end of this semester, I will ask you to write a 6-page proposal. Yeah, that's usually that's you can turn in something like just what you are working. So, but we will discuss a little bit about that later. So that's how we grading on this case. Usually it's very easy. Okay, so okay, that's some logic about this semester. Then I will set up. I will put the video archive video on the internet, and also I will make it available on online, so you can read and watch the video online and get the PowerPoint through the web tool or from another website. I will announce it. So then what you can see that in the past, we will use the Zoom meeting, ZOOM, Zoom meeting. So there are some class, for example, the hands-on course, we need to face-to-face, step-by-step working on. So you probably need me to watch your data screen, then we need to communicate. Then if you are okay, we can meet you in the campus. But if we can not meet, then we can use the Zoom meeting. In the past several years, we used the Zoom meeting for several times, then it worked quite well. So if you have time, please also download the Zoom meeting so you can join the discussion very fast. Okay, so that's all for today. Then if you have some question, you can send me email or you can send the question to my assistant, Xu Tian. He will help you to reach me. Okay, so let's start today's class. Today we will talk about the artificial intelligence in medicine and talking about a little bit the history about the past, current, and future. Because as you know that AI, we talk about AI everywhere, the Apple Watch and the television and the government, education, medicine, and you also hear the Yangming and the Jiao Tong University, they are going to merge. That I think that's all because of the AI, artificial intelligence, become a very popular topic. And you can also see that the most advanced and popular development in artificial intelligence is all in medicine. So today, I changed the slide a little bit than previous year that because regarding the hot issue about artificial intelligence, yeah, so we will use this slide to give you some history background and some concern about using the artificial intelligence. So I think, yeah, we are all from TMU. So you see the campus. We are located near the Taipei 101. Is a beautiful Xinyi district. Then I think I already talked about myself, but I want to emphasize a little bit something because since I was 10, I started to using computer, start to write the basic program and the assembly. So you can see this my Acer, the first Acer computer. So at that time, that's a very expensive one. Then I involved the computer affair in TMU quite early. I remember the first 5-6 years, I create the World Wide Web for TMU for 5-6 years when I was a student. Then after 2000 year, I graduated from university. Then I went to, before that, I got another master from TMU. Then after the TMU, I go to the University of Utah. I got my biomedical informatics degree. Then I started to teach the clinical disease support class since 2014. Then also in the next semester, I also teach the standardized terminology and the electronic health record class. So, and as you can see, yeah, this is Utah and this Salt Lake City with the beautiful scenery. And this is what I'm doing, the ROSA in my clinical practice. It's a robust, robotic surgery arm. So here give you some idea about what we are doing in the Department of Neurosurgery. Currently we use the computer and the robotic a lot. So you can see that this is our robotic arm. The computer uh, will move by themselves, so it can be very accurately. For example, here this arm, they will detect the movement of the patient breathing, so the ROSA arm can automatically do the calibration when the patient have the movement. So yeah, basically it has some artificial intelligence on it. So this is a gamma knife. Uh, the gamma knife, the idea of gamma knife here is they use the 192 radial source. So they also only deliver the treatment dose on the target and without penetrating the other brain normal tissue, they won't cause some permanent damage. So that is quite useful on treating the brain lesion. Then this is the focus ultrasound. That is the latest technology we got from Shanghai Hospital. It's quite expensive. I think it's more than three uh, 3.5 million US dollar. Then, so using this, they use the ultrasonic as a heat source. So this, you can see there's 1,000 beam of the ultrasonic, so they can deliver the heat on the brain. So for the treatment of the brain lesion, so you can see that in only in my in my department of neurosurgery, you can see that when we perform the spine surgery, you can see this. We use computer to planning. Then this the computer, the planning software when we perform the brain surgery. Then this is the planning software for the gamma knife. So you can see we use a lot of automatic segmentation to help us to make a diagnosis. Then here you can see that in order to deliver the accurate dosage of and or the heat for the brain, we need a computer to automatically calculate. So you can see that in the modern clinical practice, the AI and the robotic surgery, they has a very important role. So this another close look and how we use the robotic arm when we perform the surgery. So you can see that after we planing the screw from here to here, then the robotic arm will move to the correct, accurate position, so the surgeon can perform the surgery with more accurately. So you can see that in the modern clinical practice, we use AI and the robotic surgery a lot. Oh. Here is important quote I like to share is from the David Adis. Why we need the computer in modern medicine is because the complexity is already beyond the human's brain. So we need computer to help us uh, in the clinical practice. I think it's especially true in the neuroscience because uh, when you talk about the brain, there are too many neurons and a lot of, for example, the gene and those things. So, well, without the computer, we cannot understand the complexity. And another quote from Dr. Clint McDonald, who is also one of my advisor, is say that man is not perfectible. To error is human. Yeah, this year just passed the anniversary, the 20 years anniversary of the patient safety uh, in back to the 2000, the two error is human. That is important quote. Is because the computer they can repeat the same similar thing routinely then without any fault. So I think right now for all the clinical practice we already know that using computer is quite good because that can help you to perform the routine work and never make error. So, but back to 1990, you can see this from the quote from 1976. Back to that time that using computer in the clinical setting, it still have some question for the clinical physician. So, but I still like this too. If you change the computer into the artificial intelligence, then I think it's still true that for this two quote. Then here, I usually like to use this table to show you some idea about the clinical decision support development. Then you can see here there's two, there are some, uh, the core technique they use, like the methodology and the major use and the key development. So I highlight a couple of things like the alert, reminder, and the diagnosis and the information retrieval and the image processing and signal processing and so those things, that's what we use a lot in the clinical practice uh, for the clinical decision support system, or you can call it computer aid or whatever. And but you can see that's the traditional use of computer in the clinical practice. But I won't go into too deep about each one of these, but uh, in the following class, we will discuss about several clinical decision support systems in different hospitals. Then we will try to elaborate those definition a little bit more when we talk about all this system. But here that will give you some idea about some uh, clinical usage of clinical decision support system. And this is a timeline about the development of the computer in the history. And I think this is quite also true in Taiwan. I think the 1960 to 1985, that is quite early that I think the PC just got invented, then it's still very expensive. So just there are some place they try to do the experiment using the computer for clinical decision support. Since 1985 and to 1998, the computer is more become more cheap and more available. So there are such many successful implementation. I think is also true from at the TMU affiliate hospital. I think they installed hospital-wide computer console I think it's also around 1998. So yeah, this timeline is also kind of the TMU development. Then after the deployment of computer, then I think after 2000, you can see there are a lot of computer, then all the patient data become electronically and can be processed computer readable. So there are so many systems built on top of it. So after the 2000, there are many electronic based system based on the clinical need they create. So you can see there are many electronic health record and also the computer order entry, the CPOE and the CPOE, and also the electronic prescribing system or the personal health record. So there are lots of subsystem developed in since 2007, 2003. So, and after 2004, I think everything is all done. Then just a little bit minor improvement. So you can see there's less discussion about the medical informatics. But all you know that since the 2016, the AlphaGo beat human Go champion player, then artificial intelligence become hard again. So you can see that in the following several years that artificial intelligence will become popular again. So that's the history about the clinical teaching support system. Then, then we will start to talking about some history. The first application, the very early application, I want to acknowledge the 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 Dr. Homer Warner. I think he is also a founder of the University of Utah, and Jack Lee is I think is the last one student he teach in person before his retirement. I think back to the 1964, he already make diagnosis system based on computer. They is uh, for the detecting the congenital heart disease, because as you know that Homer Warner himself is a cardiologist. So then after that, in 1965, there's Ludwig. They will develop a bone tumor diagnosis system. So you can see that AI is not a new thing. Since 1964, um, they already have some passionate like Homer Warner. They already using computer to make diagnosis for uh, disease. Then the idiot, I think you will know, you should know that this the very first expert system that they try to using building the Bayesian network to construct the knowledge system to make differential diagnosis. That's a very early expert system. So basically, at that time they call it AI, artificial intelligence, but just uh, AI is a too fancy term for clinical physicians, so they changed their name to the clinical uh, Asper system that was more soft for clinician. So the Ming-Chin, that's another famous system built by Ted Shorley. I think Ted Shorley, you should know that is another guy who is very friendly to Jack Lee, and he visited Taiwan several times. Yeah, I think he is the team of the medical informatics department of Stanford. Then he was the dean for the Stanford for a long time. He created the expert system. Is a rule based. It's called Ming-Chin. That's the first, the idiot and the Ming-Chin. That is the very early two system that are talking about the medical informatics, clinical informatics system. Yeah, that's a very early. Then back to that's the example about the early development. Development. Then we are want to talk about what we are going. We There are some popular artificial intelligence right now. So let's take a look about some Taiwan AI development. So I think the first I want to start the AI in pathology. So as you know that most the AI development is based on the image recognition. Then for the clinical practice, I think uh, the pathology they make diagnosis is mainly based on the image. So it's intuitively that using AI and the image recognition technology for pathology is very important. So you can see this AI in pathology use cases. Then I remember just a couple of weeks ago, the Google, they published a paper. I think you probably can get the open API is you can easily attach a video or the camera on the a very cheap student use microscope and to use it to observe the pathology slide. Then the Google, they can use their TensorFlow to do the image recognition um, in real time, then and overlap the the rec the recognized result and superimpose on the image. So that's a very nice, interesting thing. So if you are interested on using the AI in pathology, so you can try to download the Google API on your own. Then that is another important thing is the artificial eye, human eye, because we know that some patient they have some problem on their eyeball, so they cannot observe this world and deliver the signal to the brain. So right now, the scientists they already decode the brain cortex, so they use the traditional camera to observe the world, then transform the signal into that the human understand. So they insert the electric pole on brain surface. So then they can create a uh, very vague image for the human. But you can see that from the blind, you cannot see anything, but they can see I remember, I think it's a 4x4 or 9x5 matrix image. Basically, for a blind person, they can use this very rough matrix image to detect this word. So I think that is a very great improvement that they can allow using uh, the electronic camera and connect to the human brain. I think that is a very amazing development on the AI. Then this another example invented by President Jack Lee. I think they can use the AI to detect skin cancer. So basically the use is you can upload your image from your skin, then it will tell you uh, it's a benign or malignant. Then I just heard a story shared from their team that there's a very young lady, age around 28 or something. They the cyst they he her she put her skin mold, um, then send it to the camera, the assistant, and the assistant told her it's a malignant one, it's a high risk one. Then she went to the hospital. Then then it it was proved that it's a malignant one. So I think that's a very convinced convincing example that using this kind of cheap, low entry AI technology can help patient to early diagnosis. So that is another example about using the AI for detect the skin cancer. And IBM Watson, I think all you know, that's a big name for artificial intelligence. Is that though there are lots of comment about talking about its usefulness about the Watson in oncology, but at least that is a very uh, early example that using the computer to help oncologists to make diagnosis and making the therapeutic uh, plan for clinician. So I think that is another uh, successful or the famous AI project I want to mention. Then that is another example for using the AI. That's using the AI for uh, recognizing the retinopathy. So as you all know that the DN patient, they have a lot of problem on their eye. They have some microaneurysm, hemorrhage, and soft exudate and hard exudate. They need to do the regular follow-up on their eye, and that is a very labor work for the ophthalmologist. So with this kind of system, the system will help you to recognizing some common pathological lesion. Then I think that will uh, relieve lots of tension for clinical doctor. I think this is also true that for the radiologist, like you know that we do the low dose lung CT screening. Um, we use the low dose CT to do the screening for the lung cancer. So that is, we will create lots of CT image. Then with the AI help, then the AI help you to detect the lesion, the abnormal lung nodule. Then the radiologists that will love this system a lot. And this is another system based on that's I think it's developed by the Professor Jack Lee, their group. So this basically the idea is currently we have a large database. We have the National Health Insurance Database. So basically, for example, the hepatocarcinoma is a malignant tumor for the liver. Basically, uh, each category of patient before they make a final diagnosis, before the diagnosis, they should have a, a, a pattern of their seeing the hospital. For example, for the hepatoma patient, before they got diagnosis, they will have the skin rash and the itching and also the yellowish color on the skin for those kind of things. So basically, they try to recognize the pattern about each category of patient, so they can using the AI try to make diagnosis a little bit earlier based on their OPD visit. So basically, the idea is they will keep tracking on their behavior of seeing the doctor. So, for example, when the system think you will have more higher risk on some uh, disease, then they will send you alert. So I think there's another similar case in our neurosurgery department is we want to detect the osteoporosis patient. So with this kind of osteoporosis screening system, we can help to make early diagnosis. That means we early diagnosis of the osteoporosis patient, then we can give them the appropriate drug, then we can save a lot of money on um, when they having a fracture or the different some abnormal thing. Then this is another example created by surgery department. Is you can see that that's a nightmare for each surgeon that you cut the wrong side of the hand or the foot of the patient. Then this system it help you to highlight the abnormal region of the patient. Then that will allow you, in this case, the patient have the right humeral head fracture. Then the system will make highlight that. Then it will allow you don't make the wrong surgery. So let's give you some history about the past and the current, what we are doing. Then we want to talk about a little bit about what's going on in the future. We want to show you some uh, what's the new uh, technology in the future. The first one I want to share with you is I think personally I like this idea a lot. I think it's a project called Artificial Raspberry Pi Pancreas. So if you know a little bit about the diabetes, then patient they need to control their glucose level very precisely every day. Then basically they need to inject. And this is a very ideally that because for the traditional physician that the physician will based on their experience to give the appropriate dosage for the patient to regulate their glucose. But patient every day their glucose level change a lot. For example, after the meal or recently they have a diarrhea, so it's hard to adjust the dosage for the insulin. Then sometimes if you control the glucose too low, then that will have some crisis for the patient. So the idea, I think I remember this invented by an engineer. Basically, he is thinking that uh, why not I can have a continuous monitoring on my glucose. Then based on some algorithm, then um, I can give the glucose, the insulin to my body uh, based on the calculator. Then that will save a lot of time is we can keep the dosage more in a more tiny or the refined uh, protocol to control the glucose. So I think this is a very brilliant idea is we continuous monitor our glucose level, then give the insulin uh, based on the appropriate dosage. But the problem is, this is not uh, a computer game. The computer game that when you make mistake or you miss it, then it's okay. But in this case, that if one of these makes some error, then the worst case is that will cause human to die. So you can see that those the idea of create this kind of equipment, it's okay. Yeah, because the engineer, he assembled those thing, he use usage on his own. It's no problem. But he sell this thing, and um, if there are some problem, and for example, you see the airplane, the Boeing 737, they have some error on there's the pilot program, so they will create a lot of huge disaster. So in the future, there I think this kind of um, the developer using the AI on treating patient will have more and more increasing development, but how to regulate it, how to secure the patient safety, that I think that is a very important issue. The second one I want to mention that is the traditionally when we treating the sepsis patient, we were based on the textbook. And but there is just a very latest paper published on Nature Medicine is they try to using the AI to search the the optimized resuscitation strategy on sepsis. So basically, is they don't care about using the textbook. They just using the big data to search the optimized treatment plan. So basically, you can see that on the left-hand side, this is done by clinician, and the right-hand side is the AI policy. So for the sepsis patient, they need to give the vasopressin dosage and also the fluid challenge. So basically, using the AI policy, they can have a more fine, detailed adjustment about the vasopressor dosage and intravenous fluid dosage. Then that will reduce mortality a lot. So you can see that I guess there were lots of paradigm shift is we will say that the doctor should not treat patient based on the textbook. I think in currently we talk about the evidence-based medicine, but in the future we will say that we need to do use the AI or the large database based uh, uh, the rule to treating the patient. So how to uh, verify or how to regulate this kind of thing, I think that will become a most important thing, because if some patient the physician they treating the patient without the textbook, without the guideline, then they having a problem, the patient's family is not satisfied, then they got in the lawsuit for the doctor, then that will create a lot of trouble. Then this another case uh, in our department is currently we are using the human to design the pedicle screw on computer, but it's kind of time consuming. So we are thinking try to using the AI to create our pedicle screw. So you can see that this the result we collect from our large database. So the computer can learn how we make the pedicle score. We were using the AI to learn. So in the future, how to regulate this kind of software and how to guarantee the patient safety, that become more and more important. So I use I mentioned these two cases that is I want to uh, talk about it is we use the AI a lot in clinical practice, but how to regulate it and how to make sure the safety issue of it, that is a very important issue before when we um, embracing the AI in the clinical practice. So let me summarize the history like this. I think at the beginning we call it the AI. Then right now, after that we call it the clinical decision support system. Then the machine learning and the data mining and big data. And right now, actually we're back to AI again. Then I want to use another figure to analog why the regulation and become more and more important is I want to analogy using the autopiloting. So you can see that this the level one, that's the traditional driver. We just drive the car on our own. And then the level one, we probably use some GPS. Then the Tesla um, is a level two last that can help you to keep the wheel on the track. So you can see that with more and more development, then the computer involved more and the human involved less. So in this case, the regulation about the quality of the autopilot is become more important. I think it's also the same that in clinical setting that in the past we using the computer only for reminder, information retrieval, and the calculator. So basically, is they just help you to get the information. Then I think that's the last harmful that when computer went wrong. But if just like the insulin pump, it using is really give the drug automatically according to the computer algorithm. But in that case, if there are something wrong, then that will cause a very important and or the lethal crisis. So just like the autopiloting, we need to categorize the autopiloting on level 0 to level 5. I think in the future, we should have some similar thing when we talk about the AI. We need to categorize them to based on the involvement of the computer. So I want to use this to summarize a couple unsolved issue for or something we need to solve for before the embracing the AI. I think the TFDA, we need to have a regulation. I think the Taiwan TFDA, they already um, have several meetings talking about how to make a nice environment to regulate those AI thing. Um, then also the pattern, how to pattern, because in the past, there is a product we can pattern on it. But right now we are using the algorithm, how to make pattern on the algorithm and how to regulate the patient data. I think they are enough talk about the health insurance data. Can we reuse it and or sell it? I think the Google currently they work with the Mayo Clinic. I think they will give us some uh, thought about the idea about how to uh, make profit based on the patient data and who own it, and should the patient can should we prohibit the enterprise to reuse our health data. And just like the auto driving, the autopilot, how to define the liability and certification, and yeah, what's the consumer health or the medical device, how we define it, and the LC and the regulation. And in the in in the last I the last part of this class, I want to discuss a little bit about the crime and the fraud about the in the AI era. So here is when show you give you the is the example that published on Science um, is announced by Isaac Kohani, who is also a pioneer, a thinker, philosopher for artificial intelligence. Here it give you an example. So you can see there's two uh, dermatoscopic image on melanocyte nevus. So you can see this the first one and this one original image and this the image process image. They actually based on the human eye is all similar. But if we use the AI to detect it, you can see this one is a benign one. Then after we add some noise, then the computer will think this is become the malignant. But basically, these two image is similar for the human. So this is very important thing that because you know in hospital when we there's a very restrict rule for how you management the pathology sample, then because we sometimes we switch the pathology sample from different patient, that is you can commit the crime. But I think in the AI era, those thing is become electronic one. I think those things compared to the pathology slide, this kind of pathology image could be hacked is more easily. So I think we should before we embrace the AI in the clinical setting that um, how to prevent this kind of crime is very important. So this is another case that we just rotate the image a little bit, then the computer will make inconsistent diagnosis from benign to malignant. Then this is another example about um, using the NLP. They use this to predict the opioid drug use abuse risk. See, you can see this the description. They use the back pain and the alcohol abuse. So based on this description, they predict is the risk high, but they change the back pain to lumbago and to the alcohol dependence, then the prediction become opioid abuse risk low. So you can see just a little bit altering the information, then we can uh, alternate the computer's results. So basically the meaning of these two con sentence have similar meaning, but the computer have the different result. So that's another very important issue. So this another reimbursement example. So you can see the metabolic syndrome, then they change to the essential hypertension, hypercholesterol, hyperglycemia, then the reimbursement, one is denied and approval. So sometimes we call this the optimized coding issue. So how to um, monitor this kind of appropriate or inappropriate the coding behavior, I think is also important. So, so I want to use this quote to make the conclusion. Yeah, because I think it's quote by Gerard Harman. I think the most important thing is we have to make sure the technology does not get ahead of our humanity and the creativity as creation. I think at the from the above example I gave you, that is we should there's lots of things we should discuss, and because don't be evil, I think um, we also always think we always advise don't be evil. So before the AI, the human or the population they had the AI, then we should have a good environment, and we will try to prevent people don't do evil. Then uh, we can have a nice environment. Then we can embrace the AI more. So okay, so that's probably all for today's class.